Okay, we're starting now. So first, thanks everyone for skipping your lunch or pulling in our desk to join this Dynamo webinar. Dynamo has been getting some traction lately. It was the hot topic of the Autodesk University in Vegas last year. And something to speak about myself here. I am a registered architect in Victoria. I worked on some of the biggest developments both in Sydney and Melbourne. And I started my BIM journey on Revit 2011, so that's quite a while ago. So just who are we in the audience today? Are we architects, interior designers, or engineers? Are we mostly Revit users, Dynamo users? Do we know Grasshopper? And do we mostly do design work or documentation work? So I'm going to open a pool here so everyone can just click on what are we in the audience today. So let's see if this works. Okay, just feel free to click in the pools to show. Okay, this is one Revit user there. That's very good. Architects. All right, so what are the new challenges being seen in the industry today? As BIM continues to break down barriers, new and exciting challenges are being uncovered, and the demand for more functionality increases. We're finding that there are increasing need for us to maintain early design knowledge. Often early ideas are lost as the project progresses from a conceptual design to a fully realized solution. And improve the transition from concept to design. So how many times we have to scrap the town planning model or the DA model because the data coming from there, it's not authentic and we can't really trust any of the data because too much quote unquote fudging has been done. And so now it's showed, everyone's looking at a poll now. All right, cool. And so next, what is Dynamo? And Dynamo, it's an open source Visualise programming extension for Revit. It doesn't require designers to be knowledgeable of programming or scripting. And it still allows designers to create forms from the simple to the awe-inspiring twisting towers. All right, cool. So now the pool is showing we have 83% of Revit users. That's very good. 3% Rhino user, and 41% architect, and 7% AutoCAD and MicroStation users. That's very good. So it's just a pretty good dominance of Revit users there. That's good. I'm talking to my buddies. All right, so and I am going to close the poll now so we can go in with the PowerPoint slides. Okay, that's that. And let's share the screen here. So, all right, everyone, it's looking at a PowerPoint here, so that's good. So let's go. So Dynamo open source Visualise programming extension. So open source, what that means is it's based on computing language open to all developers. This is why you can find packages in the Dynamo interface. That's Dynamo users who have developed their own custom node and functionality to the program and decided to share with the whole Dynamo community. And Visualise, so more and more we find ourselves dealing with data. Programs consume data, designers generate data and consume data in decision making. So what is design? Design is just a string of decisions made based on the situations and analysis present at the time. So Dynamo acts like a visual diary of the design, and it allows you to alter a certain decision in the timeline without having to undo everything till that point. So for Revit, Dynamo is developed with Revit in mind. It is an extension to Revit functionalities, and it integrates with Revit without not just with geometries, but other Revit functionalities such as sheets, views, rooms, sound paths, so anything that's specific to Revit, Dynamo understands it. So what does Dynamo do in the area of applications? So Dynamo uses algorithms to generate a huge list of Revit objects. Objects can be either instances of families or shapes in the mass, as long as those objects follow the underpinning rules and logic. So Dynamo pretty much simplifies the complexity. As designers, we build up complexity to resolve problems. and arrive at a better outcome, such as the angle of the tilting of the facade panel, which is going to be driven by the solar heat gain throughout the day of that panel. And Dynamo can serve as the medium between a good idea and a graphical prototype. So that is pretty much summing up the computational design aspect of things. Also, because Dynamo fully integrates with Revit, so it can perform some of the mundane day-to-day tasks, like generating a huge list of sheets and giving you a control over a lot of the Revit functionalities. So how does computational design factor in? Many designers and engineers are looking at computational design as a means to resolve a lot of those challenges. It allows users to make beautiful, high-performance and economic structures without learning how to write scripts. And it allows designers to focus on ideas and then let the documents flow out of the process effortlessly without having to rebuild and rework a lot of the data. And the Dynamo's integration with Revit creates a fluid relationship between building concepts, design development, construction documentation, fabrication, operation. And so let's just quickly explore parametric design concepts. So with Dynamo, users can quickly explore parametric design concepts. We can rapidly test, iterate, and study multiple design options in less time. And it solves complex geometric problems. No programming experience needed because it's all very much graphical. And it automates repetitive tasks for more precision and speed. It manages risk by exposing trade-offs and understands system connections at a conceptual phase. It generates sophisticated designs from simple data logic analysis. And easy analyze and visualize geometry. And user can create a world-class geometry library to create solids and the surface that compatible with most of the downstream needs, which is the Revit operations. And it's a shared collaborative environment without the need for exporting, because it works natively inside of the Revit project or family environments. And it connects with other applications, including Revit, Excel, which is what architects deal with a lot. So how to download Dynamo? All right, let's look at the screen here. The Dynamo is pretty easy. And so the official Dynamo website, I believe everyone is looking at it now. It's dynamobeam.org. So to download Dynamo, once we're in this main page, just click on download Dynamo. Simple as that. So let's just wait the page to load here. So here, when we look at Dynamo, actually come in two flavors. The first one is the Dynamo4Revit add-in. So it functions on top of Revit. So to use this one, because it's a free software, so it literally acts as an add-in for Revit. It works with Revit 2015 and 16, and it's a free download. And the Dynamo Studio, which is a standalone programming environment, and which you can this is a paid software, and you can use the software without having to have a Revit license. So what we're gonna go through today is the Dynamo4Revit plugin. So let's see what Dynamo looks like once it's installed. Okay, let's just switch the window to Revit here. So this is a Revit project environment. Once Dynamo is installed, it comes in under the Add-in tab. And this is the Dynamo icon. And right now, I think the most recent revision version of it, it's 0.9. Let's just click on that and wait for Dynamo to fire up. And yep, let's look at this. Okay, all right, Dynamo is on the screen now. So this is your pretty box standard starting screen here. So here you have your files. This is creating a new Dynamo script, creating a new custom node, open an existing script, and this is the recent files. And to the right here, the Dynamo forum website, And one thing worth mentioning here is the Dynamo Primer, which is like an online library of very detailed explanation of all the Dynamo functionalities. So if you run into questions with some of the Dynamo nodes or what is a list, and that is your best bet, Dynamo Primer. And the video tutorials, which is a library of videos which demonstrates and goes through a couple of Dynamo's functions, which is also very useful. So let's just get into the user interface. So this is your Dynamo user interface. From top down, you have your menu bar, toolbar, and the library and the workspace side by side. And at the bottom, this is called the execution bar. So here you have the automatic and manual function. So automatic is when you have very simple scripts. It just runs automatically every time you make any changes. But when you have more complex and sophisticated scripts, I find it's easier when you just set it to manual and control the run by yourself. Because sometimes if there's glitches or warnings, it's best managed through this manual mode. And here, the packages we mentioned, as this is open source programming, here it's actually where you find all the Dynamo and custom-made Dynamo functionalities. So this is connecting to a worldwide library of the custom nodes that's created by the other Dynamo users. So I believe that is on the screen now. Yeah. So this is it gives you the description, and sometimes you find there's some pleasant surprises there. And one of the pretty popular packages is called Launchbox, and that replicates a lot of the functionalities that's in Revit. For example, creating a quad grid, diamond grids. So all of that can be replicated by the Launchbox. That's just one of the things it's pretty good at. And then now let us get into some really simple Dynamo nodes to get a taste of the script. So yeah, and what we're looking at here, it's your typical Dynamo scripting environment. And the little squares here in Dynamo, it's called a node. And each node carries its own special function. So here, let's zoom in here. And this range node, so the tooltip already give it away. So it creates a sequence of numbers of letters in the specific range. So basically what we're telling Dynamo here, it starts from the number 0 and it ends with the number 9, and the step is 1. So let us just run the script and see what happens. Okay, it's pretty fast. So in Dynamo, all the data start floating from the left to the right, which is not anything different from Grasshopper. And you see the watch node, it displays the result of the node that connect with it. And also here, this preview node in the range nodes. So when the preview button here, so when you click on it, it gives you the result of the calculation here, which is exactly the same that's displayed in the watch node. And in this node, it's telling the calculation to take the last item of the list, which here displays as the number 9, which is the last item here. Then this drop function, it takes the data coming from the range node and it drop it by 3. So instead of a full list, it gives sublists inside the list. So sublist by the number of 3 until you finish the whole length of the list. So something that's quite unique with Dynamo, it's about this list management. Because when we're using Revit, placing families or curtain panels manually, we are using our hands and eyes to finish the task. But when you trying to use Dynamo to automate this process, the list management is something that enables the program to automate a lot of those tasks without us pointing and clicking. So to make the list to appear in the correct format and showing the right data is crucial for Dynamo and Revit to integrate seamlessly together. So Dynamo, it's at its best when working tandem with Revit. When Revit creates a comprehensive database for every project, it can be difficult for an average user to access information outside of the Revit interface. However, Revit hosts a comprehensive API, so text-based scripting can be accessible for everyone, which is what Dynamo is. Using the core Dynamo nodes in tandem with the custom Revit ones, a user can substantially expand parametric workflows. And so let's just go through this couple of the three main functions of Dynamo. So when we talk about integrating with Revit, so the first thing is we need to select things from Revit. So when we're in the library, we type in select, it brings up all the nodes inside of the Dynamo library, which has the select in their names. So here we can see Dynamo can select a lot of Revit objects, views, levels, or select the face if you are in a family or a mesh environment, and the select family types, element types. So anything Revit creates, Dynamo can select it. So let's just go down here. So let's select. So this is the first type of select, which is your good old point and click. You click this button here, and it will prompt you to select the object in Revit. Then the linkage is established. Then Dynamo knows this node is linking into a Revit object. And there are other two ways of Revit, because we're speaking of Revit here. A lot of things can be done smartly. So select categories. So this thing, this node here, let me just zoom in here so everyone can get a better look. So this way of selecting is through drop-down menus. So this will actually show up all the categories that's in Revit. So you can, for example, if you want to select all the cable tray, you have the options to do that. If you want to select all the casework, you have the options to do that as well. And the other one is, now we're using Revit, we're dealing with families a lot. So if, for example, if you want to select all the task Shivada task chairs, and it's selecting by family is your best bet. That give you the whole list of all the families inside Revit, and you can select them by family names and types. All right, so this is a pretty simple overview of the functions of Dynamo. So next, let us look at how Dynamo works in a real Revit project environment. So let's close this. Okay. So this project, this is a typical medical center here, and you see the roof here, which is a dome. So I'm just gonna twist the view to show that. So this is a medical center with a dome roof, and the dome is created with in-place mesh. And what we're trying to get Dynamo to do is we're gonna automate the process of creating a quad grid on this dome roof and place the adaptive component families onto this shape. All right. So let us bring up Dynamo. All right. So again, the data in Dynamo flows from left to right. So let's start from the first node here. So the first node is just the point and click we just been through. We select the object, and we turn this object into surface which is understood by Dynamo. And if we find out the surface is created upside down or inside out, we can use this flip normal direction node to flip the surface to have the upside facing up. And let me just slowly move over here. So this is the launch box quad grid we just been through. So I downloaded the package from the community. So this will take the surface and with another two inputs of the U value and the V value, so that will divide the surface up into 10 by 10, which is 100 panels. And then the next thing, the node down here, which is geometry translate. So the input here tells Dynamo to offset this geometry 150 mil up. And the offsetted surface will go through exactly the same option, 10 by 10 UV grids into 100 panels. And those two nodes, well, the quad grid node spits out three sets of data: points, polygon, and faces. So what we're gonna do here is we're gonna take the points from both surfaces, and we're gonna go through a list management process to make that be of the format that will be accepted by the Revit family. So let's disconnect this node here. And so by disconnecting that, I'm telling Dynamo all the operations will stop at this node, the final node. So let's just click run here. So when Dynamo is running, I will just quickly explain this group of nodes. And so when the list of points come out, it come out in a sub list. So that's why we go through the list flatten exercise. And after we get the flattened list from both quad grid nodes, we need to combine them and make that be in the fashion of a sub list of 8 points, because every panel it's a cubical panel and it has 8 points, and the Revit needs to have 8 points for this family to be placed. And let's have a preview here, see what is the result we're getting. So this is arranged in the fashion that would be taken by Revit. So 8 points from 0 to 7, 8 points in a sublist. And if we scroll all the way down, we will see there are 100 items. So from 0 to 99, we have 100 items inside of this list, which is correct because we have U grid and the V grid both being 10, so 100 panels. Then we connect this with a point node. So this one, it takes a family type and it takes a point information and it creates all those adaptive components based on the points that's given. So let's hit run here and give Dynamo a minute to think. All right, so let's see what Dynamo has actually done in the Revit environment. So we see here, all right. So the adaptive component family is placed onto this shape. So if we click on that, you see that's the sequence of the points here. So it actually took a couple of tries for this to be in the right order, because and so the numbering of the points is quite important. The numbering of the points has to be exactly the same sequence that's spit out by Dynamo for this operation to go through. So it takes some fiddling around. And so all of that has been pretty easy. If we stop here, that would just be too easy, wouldn't it? So the next thing I'm gonna show everyone, it's doing the solar analysis on each and every individual panel. So the theory behind this is quite simple. Revit is a software that's designed with the sun path in mind. As you can set any given position of the sun at a given time. So we take the sun position and we turn that into a vector information. And the next thing we need to do is we take this top surface and we take the polygon node connecting here and the panel faces connecting here. So what this does is we take the polygon and get a center of the polygon, and then we take the normal direction at surface level. So basically this is querying which direction this panel is facing, which is another vector information. And so we compare those two vector information using this dot production node. And because we architects, we're not math majors, so dot production, it's a confusing concept, it can be. So all it is we need to know is it gives us a result based on the cosine value of the angle between those two vectors. So the bigger the angle, the higher the value of the dot product will be. And the next one is this mass absolute. So because this node will return some of the negative info, because if the angle goes over 90 degrees, it will become a negative value. So we are only interested in the absolute value of this calculation. So let's give it a run and see what results we get here. So again, a list of 100 items with different values assigned to them, which effectively carry the information of this and every panel is facing towards the sun or facing away from the sun. So the next group of nodes I'm going to show here, this is actually when things get colorful. So here we define two colors, and 255 green, which is green, 255R, which is red. So from green to red, and we combine that, and that goes into the color node. Then the indices will set from 0 to 1. The next thing we need to make this value, because this value it's I think that the highest one is around 90. So we want all of them to be remapped to a range between 0 and 1, which corresponds with the indices we set here. And after that, we'll be getting some colors on the panel. So let's have a run here. So the last node is the node that gives the panel the color. So let's give it a run here. And then now I'm gonna show everyone, and inside Dynamo is still a graphic representation of the actual Revit objects. So if we zoom in here, so this is the Dynamo's internal graphic engine. And what we're getting here is that we can see the panels here, the red ones, which means it's facing towards the sun. And the less red, the more green it gets, it means the panel is increasingly facing away from the sun. So this is quite useful because it gives you very visual representation of your calculation results. Then the next thing we're gonna go through here is we're gonna create two types of families based on the RGB value of it. But by RGB I mean actually the red value of it. So more red means it receives more sun, less red, less sun, solar heat gain. So we're gonna separate those two groups of panels using this node. It's this node, x greater than y node. So we connect the color value. So again, list management here, flatten the list. And here we're telling Dynamo if this red value is higher than 150, it goes to this stream. If it's lower than 150, it goes to another stream of data. And then we take both. Take the points from both quadrids, and we make that go through this Boolean filter. And so this is the same chop and combine function it goes to, which is exactly the same with what we just showed before. Flatten the list, combine the list, and make that list to be in a subgroup of 8 fashion. And then we define two families. So let's just zoom in here. Then we define two families. So what this is telling us, it's if the R value is above 150, place a transparent panel. If it's below 150, and we will place a solid panel. So let's just give this a run here and see what we'll be getting at the end. It's taking a little while here. Okay, oh, we already got the results. So let's see what we have in Revit. Okay, so this is pretty straightforward. So the red panels have the transparent type of panels placed in the position, and here it's opaque ones, which is the green panels. And the good thing about Dynamo is you can change your design however you like it, because this, sorry, let's just move in here. So this 150 value, it's just decided by me. I just randomly came out with 150. If you want to refine the design, for example, you want to say instead of 150, how about 65? And you can run the script again, and you will get another result. So you can repeat this process as much as you want until you get a desired result. So it's already finished. So let's have a look at what Dynamo spits out in Revit this time. So again, more panels are transparent now because we reduced the split threshold. And less panels are opaque. So you can repeat this process as much as you want. And the other thing is that you can save this script and use on another different on a different project, because this is just a dome roof. Because tomorrow you could be working on a facade, and that it's requiring some of the solar analysis, and use Dynamo's value to drive a different parameter. And that is Dynamo in a real in the design perspective of it. So next thing, let's look at using Dynamo for a day-to-day Revit task, which is creating a lot of lists, sheets. So let's close this. All right, to demonstrate this, I'm just gonna use a blank project. So if I like when you're starting a project, or a project going from the DA phase into the CD phase, you suddenly find out there's a range of lists, sheets we have to create, and that can be a very mundane job. So let's look at how Dynamo can help us in that. So yeah, this is a blank project. As we can see here, we only have one sheet that's created in this project. And it's with box standard and Autodesk title block, so nothing surprising there. And so okay, let me just show my Excel sheet here. So yeah, so this is the Excel sheet. We usually already have this before we even jump into Revit as the architects. This can be in part of your project bidding or project deliverables. Those sheets are already there, and we can just take those information out of Excel and put that in, arrange the data in this way. And this is in sheet number 1, so this is pretty box standard. And I'm just gonna show the Dynamo application in this kind of operation. So again, same thing, back in Revit, and we click Dynamo and just wait for it to fire up. Okay, automate sheets. All right. So what we're looking at here, this is a much simpler script this time. So what we're looking at here is we define a path which Dynamo reads the Excel file from, and then because all the transmitters living in sheet 1. So sheet 1 is the sheet name, and read as strings. That's false because we want the sheet numbers to be read as numbers. And so the next note I need to elaborate here. So because Excel organizes everything in a column kind of fashion, so all your drawing numbers live in column A, and all your drawing sheet names live in column B. So, but in Revit organizes data in a row by row kind of fashion. So everything is organized in rows. So this is why we need to use the node called transpose. So you're literally just taking the data from Excel and then rotate it 90 degrees, which can be processed by Revit. Then So got this one. Those two nodes basically it's getting the list from row number 1 and row number 2, and so that value goes into this node, which is the sheet creation node. So the sheet name links here, the sheet number links there. The title block would just be the box standard Autodesk title block. And here from what I discovered, you have to put in a view here for this node to function. So we just place one view on the sheet. Because also, if we have a list of views here, we can automate the view placement as well. But here we don't have the views because it's a blank project so far. So let's just hit run and see what happens. All right. Okay, it finished pretty quickly. So let us go into Revit and have a look what it gave us. So yeah, there you go. Good job. So all the sheets are created. It's literally just simple like that. Join numbers is there, and the sheet names are here. That's it. So that pretty much wraps up the Dynamo webinar for today. So do we have any questions? And if we have any questions, we can just type in here. Yeah. All right. Cool. All right. Who says, can you please unmute me? I'm just trying to unmute here. Yeah. Hi, Kyle. You got a mic here? Hello? Sorry, technical difficulty here. So, Kyle, please unmute me. So, hello. So, Andy Humphrey, you're speaking now?